Hi, welcome to Scholar Sauce. Today, my son and I are going to be reacting to Alan Becker's video Animation versus Coding. In the past, I've reacted to animations versus mathematics, animations versus geometry, and animation versus physics. And you can find a playlist of those videos in the description below. But today, I want to react to animation versus coding with my son Ethan here, who's a computer science major at the same university that I teach at, because he knows a little bit more about coding than I do, and I think it'd just be interesting to see how we both react to those kinds of things. Personally, my coding experience mainly centralizes around trying to use coding to solve mathematics problems. So I've coded in computer algebra systems like Maple. I've also coded a little bit in MATLAB, and most recently I've been learning a little bit of Python in order to code in the Manum module for Python that was created by 3Blue1Brown in order to create mathematics animation. Ethan has a little bit more coding experience to me, so Ethan, why don't you tell us a little bit about your experience?
I know a decent amount of HTML, CSS, a tiny bit of JavaScript, and I've learned Python like halfway 3 times. But never in like a full way. I'm in CS 1400 right now, so I've been learning that as I go.
Awesome. As a little bit of a disclaimer, we had to re-record this intro after we reacted to the video because we had some recording problems that caused the recording to be really choppy. As a result, we didn't think that it would make sense to try to react to everything because those wouldn't be the natural reactions we had. So instead, we had to work really hard in post-production to try to come up with a way to still express our reactions with the choppy video, and I think we figured out a way to make it so that it's still an enjoyable experience for everybody out there, so that it avoids it feeling like it's a choppy video or anything like that. Fortunately, the audio worked out really well, so you'll still be able to see our genuine reactions. We also will re-record the outro to this video, and so we'll see in a little bit, but here is our reaction to animation versus coding. He's using an app.
You.
So what's the name error?
A name error is when you try to use a variable that is completely undefined.
Oh, okay, so that's what he did. He tried to write in a variable. Like he wrote hello and it wasn't defined.
Oh, yeah.
Yeah.
The rite of passage, do it.
Well, he's printing, but there's nothing in there to print, right? So
do the rite of passage.
Yeah. So the print command, of course, just prints whatever you wrote. That's why when he did it the first time, nothing came out.
I'm kind of sad he didn't do the rite of passage.
What's the rite of passage?
Everything has to start with hello.
I guess he had the hello, but not the world part. But all right, let's keep going. I guess 3 of them. Now this is actually kind of interesting, right? This looks probably Python-y.
Well,
right?
It is Python.
Right.
He's not repeatedly running it, and instead of it like shooting out it again, it's just shifting it.
One of the things that I think is interesting about coding languages, there's like baseline coding stuff that's the same regardless of what coding language you do. Like you can define a variable, you can print, you can do loops, all that kind of stuff. But like the syntax is all different. So like when I first learned to code, I did it in Maple, which is actually like a computer algebra system, and it has a coding language as like kind of a secondary thought, so you could like code simple functions in, so you could do like math things. Its definition to define a variable had to be different because it had to be able to solve equations and stuff like that. So it used a colon equal to define a variable as opposed to just setting an equal. Does that make sense?
Having the equal sign in it
just meant it was an equation. Like the thought of that is like text.
That's what I mean, like.
So you had to do kind of a few things that are sort of different. Okay, so this was interesting. He went through all the different operations.
Well, not all of them. There's a few more.
I mean, he went through like just the arithmetic ones. Like he did.
There is more arithmetic operations.
He has plus, minus, times, division. So that's 3. Now he's going to do double division, right? What does that do?
So, if I remember correctly, it basically just divides and then gives an integer. So it cuts off.
Okay, so like
it rounds.
It's a floor thing,
yeah.
Right? Because it's got to be a floor because it's not round.
And then if you do 2 asterisks, you can do
exponents. Yeah. A string, of course, is just just a word, but it has to be in quotation marks so that it knows to print that as text and not to try to interpret that as like a bunch of variables
if
together.
If you do it without the quotations, then it is
thinks
a
it's a variable. Right.
The quotations is how you define it as a string.
And so this is cool. I didn't know you could do this. So he's adding a string to it and just concatenates it.
Yeah.
This was funny because in Maple, when we had to do that, there was a concatenation command to cause two strings to glue together.
You can even do it with lists.
Yeah, you could just add a list together and it just
you can add two lists together and then they just put them inside of each other, with the last one being just having all of its values put into it.
See, that actually would bug the crap out of me. Because when I would add two lists, I would think of it as like adding vectors, so it would add like the corresponding components instead of just gluing the lists together.
You're using lists as more than just
more than just that, yeah. In coding, yeah.
That would get really weird when you have a list of strings.
Yeah. All of my coding experience is all based off of like building things in math or whatever. So like between Maple and MATLAB's a little bit more like this, but it's just like colored by this computational kind of thing that I'm trying to do.
There is times when math, it just makes coding nicer, especially in one case where every time I've been going into like two-dimensional lists, they say a two-dimensional list.
Like, and it's like rows and columns, like an array?
Yeah. Like, I just think to call it an array or a matrix.
Oh.
Because those work so much better.
But Python calls it a list? It's just a 2D list?
Yeah. I get like that it technically is that, but like when you're being taught that saying matrix or like array just works better.
Well, and I guess it does kind of have the advantage because I suppose you can make like a 3D or a 4D list that just has multiple indices, right? All right, let's keep going.
I know type errors.
So I assume now he's added two things together here. This is a type error. Why is it a type error? What's going on?
Well, type errors are one of the more common ones that happen
because they're different types of things.
It's different types of things. Often, I've had this happen like once when I was trying to do things with things that had a number in the string, and I forgot to put my quotations on one. So I was trying to add to it. But
and I think that's what's happening here, right? He's trying to add
certain things to each other, but not everything.
This is erroring then because so A, the variable A is the integer 5.
Yeah, you can't.
And B is a string,
and
so
to a string.
Yeah, so that's why it's type erroring. So the str command converts it to a string.
Yes.
Length is the number of letters in the string.
No, that's just not a thing.
What do you think he's trying to do?
To
me, it suggests that he's like, is he going to try to grab like a certain character? Like, so he's made A the string.
The brackets for lists.
To like, and then you call
it was probably a typo.
But that's a list, right? So is he able to pull out like a specific element of the list?
I mean, yeah, there's ways to do that.
Because that's what I've seen before.
Yeah.
So like, if he'd put an integer in there,
because if that was a list, then you could do A and then a number in the list, and it would take that specific slot.
Right. So this is like a 6-character string. If he'd put like A3, it would have pulled off the third character, which is the R.
Yeah. Okay. Yeah.
Now this is important too. Okay.
I think I've done that one time, like one time ever. The only time I can see myself ever necessarily needing it is like if I'm trying to abbreviate a name.
Yeah. I can also see if you were trying to alphabetize, you'd have to be able to do that, right? Yeah. Now, one thing that's interesting here that I think some people who view this might not be aware, depending on the coding language you use, a list will start with the first index being 0 or 1. And it seems like most modern coding languages start with the index being 0.
Almost every. It doesn't have to do with like how modern it is. It has to do with how user-friendly it's trying to be. Like when you have a coding language that isn't designed for computer programmers or people who like kind of like know deeper things to it.
Yeah.
They'll make it start with 1. Internally, it's 0.
Yeah. I'm trying to remember, because I remember having this issue when I tried to code in MATLAB. Because like when you're writing something out in math and you have to index, like a list, you always index with 1 first. You know, when you're just writing it by hand. You know, like the first vector in a list would be V1 and then V2 and V3 or whatever.
Oh, yes.
We wouldn't normally start with V0.
The first vector is slot 0. Like we even will still do it. Like we won't say the 0 thing in it. We'll say the first
vector is slot 0, yeah. We would do that if we did a mesh. To take an interval and break it out into pieces, we would do A0, A1, A2, so that the number that you ended with, the last index was the number of pieces, but you have to have one more than that because you have to get all the endpoints.
Well, yeah, we have that when you do like a range of a list. The first one is inclusive, and if that one was the exclusive one, you couldn't do the first one.
What do you mean by inclusive and exclusive?
Basically, so you put in 2 numbers. The first one you put in, it's going to start at that portion, and the second one you put is going to end at it, but not
the beginning index to the end index of what you're trying to do.
But if the first one was exclusive, you can't just go negative like that. I mean, you can, but it would be weird. Negative goes from the end.
Grabs it from the end?
Yeah.
Okay, so like -1 would be like the last one.
It's the last one.
Yeah. The interesting thing about this, so I think MATLAB tried to do what you were saying and tried to make it sort of user-friendly. But I remember having an issue with this because my meshes would start with 0, but MATLAB's index started at 1. And so whenever I tried to match those two, they wouldn't line up, and I'd constantly have to put in this like I+1 or I-1 in all my lists. So anyways, that's interesting. But that's what's going on here. So this A0 is pulling off the first element of that string. That's why it's printing an S down here by the computer over here. It keeps bumping it so it goes forward one. Okay, for I and A, let's talk about what a for loop is.
We're going a step further than just basic for loops.
Yeah.
Because this is for looping through a list.
Through a list, yeah. So this for I, so this sets up an index, and the in A means that you're going to take every index that is in A, every single one of those, right? And so then he prints off what each of those indices are, and it's actually just printing off the characters that are in each of those indices, right? So the I doesn't necessarily have to be a number. In this case, it's for I in the set string, and it just runs through all of those, and that's why it printed out S, T, then R, then I, and so on, right?
And now it's the part when everything turns against him.
It's barking at him. While true. Okay, let's go back. Let's talk about the while true.
That's just an infinite loop.
Right, that's it. So it's going to infinitely bark at him, right?
Yeah. When you have a while loop, it's actually just checking if a Boolean is true.
Right.
Okay, and that Boolean can be done in the form of like a mathematical value, or you can just have it be set as true, which is always true.
Oh, okay.
Therefore, the Boolean value is true.
And so then it just keeps doing this forever and just keeps barking at him. What's the dot upper?
I've never used that, but just judging off of this, it probably just...
it's capitalized. Yeah, that's what it is, yeah. See, this is something that I learned about. You can do things to the variable by having this dot and then like a command, right? So that was something that I didn't know about Python before. That's very different than the other programming languages that I had done. So that's pretty cool. So that's what this is doing. This upper is an uppercase thing, and this is applying it to the whole string.
And then when you do commands like that, you always have to have those parentheses on it. Sometimes you're going to have parameters. Right,
right. And if it doesn't have any parameters, it still has to have that so that it knows that there weren't any parameters to plug in. Okay, so he stopped it. Now here's that Boolean thing you were talking about, right? So while a dot isDigit is a function on this that's going to produce true or false on whether or not a is a digit. Since a is a string, it's producing false, right?
That is kind of weird to me. Okay, because normally more complex commands like that aren't things you'd expect to have in base Python.
Well, I'll tell you, I think probably where this comes from, when I used to write code in Maple, I did it as part of an undergraduate research project in math. And whenever I'd write these programs that we needed to use, we would write code that was easy to troubleshoot. So if you like put something in and it didn't give it out right, we wanted to be able to produce an error message that was useful.
Yeah.
You know, if we were expecting like a vector in this slot, and you gave us something entirely different, we had to have a way of detecting that that wasn't what we wanted so that we could tell the user, hey, look, the thing you gave us wasn't what we wanted. I assume this is probably something like that.
There's the try and error commands, which are direct ones where you can do a test
you can do that kind of
and
stuff.
Then give an error message if that test failed.
Well, maybe, I mean, this is like one of those things I'm saying is like a test.
Yeah.
Anyway, that's what it's doing. So let's talk about the...
shifted slightly. What was going on with it?
Yeah, so he
oh, never mind. That... Yeah, he did shift it. When he ran it, there was no indentation there.
Oh, okay, but now
whenever you have anything that's just ending with a colon, you need to have indentation
after the colon.
Yeah, the next thing needs to have an indentation.
That's interesting. That's
kind of the general rule to no win. The colon is saying that the next thing is inside of this.
Oh, okay. So then you have to indent.
The indentation's really nice because just this thing is nested inside of this thing.
Okay. And so that's how you define sort of what's going on with
the layers of where everything is.
Actually, that's one of the things that I've liked about using Python with the Manum stuff was because it forced this sort of indentation. When I did like loops like this in Maple, you actually had to delimit it, like tell it. So it would be like for I in this range do with the DO, and then you do the loop, and you'd end the loop with OD. And so it was like the beginning and the end of the loop. Oh, it was definitely weird, but that's how it delimited it.
And JavaScript just do that by a bunch of different parentheses, brackets, and the squiggly ones.
Braces. Python was really clever by forcing indentation to be the delimiter. Forces the code to be a lot cleaner, too. So now he's changed it to digits. Not A is printable. So I assume that the while not A is printable. So the
not just reverses it. If the Boolean
it.
value is false, then it runs.
So A is printable, so it would be true.
Once
so
I got a command I never used, probably just
for something like that.
Can
yeah.
print, it's likely just a try error command.
Yeah. Anyway, so you have the is printable part is giving a true because the rar is printable. It's a string, but then the not will be so it'll be false, so it won't run. And so then he puts in this else, which means print the thing anyway. And so now it's going to start throwing rars at him. You threw a bomb at him?
Well,
so here's a list of a bunch of different bombs, and then he's... Oh, what does the star mean? Let me go back. So what do these stars, these asterisks on the bomb do? Does that print like everything that's in the list?
I think it just prints a random one.
So let's see what it is. So what did that throw? I think it's doing all of them. I think it prints all of them.
Oh wait! It prints them all separately.
A separate different...
I was reminded. As it doesn't print the list, it prints everything inside the list separately.
Oh, I gotcha. Okay. So that's why when he
I'm
throws
having to go into the depths of my mind for the things that I don't think of.
Yeah, so that's what he's doing. Import turtle.
We're bringing turtle into this.
Okay, so what's turtle?
Turtle's fun. Turtle is this little arrow thing that can go and draw stuff.
Oh, okay. So it's like a package.
Yeah.
So this
he's importing a module.
That's what you call it in Python as a module. Yeah. So what he's calling here is he's pulling up the turtle command from the turtle module.
And turtle equals turtle.turtle is a setup you do.
Okay.
Basically, you're defining the turtle itself as T.
And then the dot forward 400 means the turtle's going to move forward 400. Is that right? All right. So let's see what happens. There's the turtle.
Yippee!
Went left, up. Okay, so you speed fast. So so if you do two of them, it changes like a vector in the direction. Import string as ammo.
He is popping from the list, which removes a piece of the list and then returns it.
So he's loaded like everything in ASCII uppercase or whatever. He's going to pop it out by throwing out all the things. Pen size, speed, fastest. So it got thicker, faster. Yeah.
When someone in the class went deep enough into the documentation to find that you could change the speed, everybody was super thankful because it meant that it didn't have to take 2 minutes for one test.
Oh, because you could make it go through the thing.
And then everybody ran it on fastest for the rest of the
class. Oh, that's funny. So did you guys learn about turtle?
We used turtle for a bit because it works on a same kind of method. The thing where we're using to code drones was built on turtle. So we used turtle to practice with it before we started running on the drone.
Basically, the same commands that you use to control the turtle is what you use to control the drone. So
he ran out of character.
matplotlib. So we imported a. What did we import?
He's importing a whole library.
So mathplot library, Python plot or whatever as PLT. NumPy is the math commands, right?
NumPy contains random inside of it, among other things.
So he imported NumPy as NP. So now NP is the collection of that whole module. And if you want to pull out a command from that module, you do the NP dot the commands.
So he's importing the library, and then the module is random, and then he's pulling random from it.
So what's the 1, 10, 10 mean?
It's the range of 1 to 10.
1 to 10.
And then...
See, part of the problem with all these coding languages, you have to know the syntax of all these different commands. So when you want to do something, a lot of times what you do is you end up Googling, this is the thing I want to do, what command does it? You find out what command it is, and then you find out what the syntax is of the command.
Well, normally when you're using a library, you're going to have the documentation pulled up in another window somewhere. That way, if it's like, can I do this? Control F, find the section.
Find the section on it, yeah. That's what's great about coding is that once you have the hang of like sort of the general idea,
you just have to be able to think
library.
like it's a puzzle kind of.
Yeah.
You have to be able to pull it apart into the steps you need, and then once you have it, all you need to do is figure out how to do each of those steps within the language.
Yeah. And then he shows the histogram or whatever, the bar plot. It's got to be picking. It's got to be picking.
I don't know why.
Not just 1 and 10. I don't think it was what you think it was, because this is pulling off a random number between 1 and 10. Oh, maybe it's the number of them that I picked, because there's maybe 10 boxes. Oh! Yeah, there's 10 boxes. That's what it is. Yeah, he has 20 now, because he made it bigger. So he's throwing all these vowels out. So these are all various commands you can use to make a plot within this library, yeah. There's a cosine function, so you can see that there's a whole bunch of different math things that you can do inside of it that's already built into the library.
basically an inbuilt calculator.
Right. Pygame. So Pygame, do you know what? Have you heard of that before? Do you know what Pygame is? I assume. I mean, it's a module of some kind, or is it like a gaming kind of thing?
It's probably a game engine that he's initializing it.
What's cool about this, you kind of see the structure of the code, right? That here he's got another while loop. He's got things going on.
If you look
it's going to draw
enough, you can reverse engineer a lot of things.
Yeah. So I kind of wonder. So this draw rectangle, screen red, square position. I wonder if this is going to be. I don't know. It'd be interesting to see. So watch for this rectangle or whatever to see where each of these pieces do. Here we go. Oh, yeah. See, that's the object. So now he's changing the movement of the thing. That if you press up, it goes up. So he's coding in movement controls.
I was really hoping he was going to bring Snake into it.
But that's what those codes like. Let's go back actually real quick. This is interesting, right? Okay, so. Hang on. So in this one here, he's going to describe what each key is going to do. So
I like the way that Alan Becker has been handling a lot of things with it, like flashing, and you can see what's going on.
Yeah.
Like with a lot of it, it was like flashing and saying false.
Right.
Instead of the for loops.
Yeah. So you kind of understand what was going on with it. So now this is cool, right? So he's set up.
Just added the most basic controls you can have to it.
What happens if you press the up, down, left, right key? So that's what each of these things are. And it says that if you press the up key, it moves the position Y up 20, and it's a negative. That's another thing that's weird about computer graphics. Positive is down, negative is up, right? And so that's why when you press up, it's going to go negative 20 in the Y direction.
Because you start with the top left.
Yeah, the top left is the 0, 0, and it goes down and to the right.
But we just do it because top left.
Yeah.
You read.
So one of the things that's cool about this, like from a mathematical perspective, right? And I teach about this when I teach about coordinate systems, is that whenever you're trying to like pick a coordinate system, like you pick whatever's convenient for what you're doing. And that's what the computer scientists have done. They picked a really convenient way to code what they wanted to do with the entire screen. And it made more sense to make one of the corners the origin as opposed to making the center of the screen the origin. It avoids having to have negative numbers as coordinates and a whole bunch of things like that. Anyway, the reason why I stopped it was because he's coded in what each of those up and down buttons do.
I was really hoping this was going to be Snake, but...
Yeah. What I think is cool for viewers who are probably not familiar with coding is that you get to see sort of like precisely how, like this is really basic, but it's just coding in, you press this button, it does this action. That, concept is what works on all controls. It's just the action may be complicated. It's still, you press the button this way, it's going to do that kind of thing. So that's pretty cool.
Max.
Yeah.
They fight back.
They fight back. Wait, Max fight back. PCs are subservient? I don't know if that's what they want to have.
Max are PCs.
Well, yeah, I guess that's true, but I don't know if they'd like to call that. But, yeah.
It's something above PC.
Well, no, I mean, like, I was thinking PC in terms of like a Windows machine is colloquially referred to. What is going on there? So if circle position is 0...
he added a bunch of stuff at the top, too.
So
he's creating a circle, shifting it over there. I forgot to mention this earlier, but I mean, he's doing ticks, which is always important.
So what's the ticks do?
So when you do games a lot of the time, you want to go create basically something that you don't have in real life, which is the shortest amount of time possible. Okay, the majority of things going on in a game are always going to be inside of one big endless loop that only breaks when you quit the game. That infinite loop needs to have one wait time on it.
One time unit.
No, one wait time at the bottom of it. That it'll wait after finishing the loop to do it again. That is a tick.
And so that's why the clock dot tick 60 down is at the bottom. I mean, I assume that means he's going to let it tick 60 seconds.
No, that's 60 milliseconds between each tick. Clock dot tick is probably just a wait command.
I think he's going to make the circle just bounce
honestly.
Is that what it looks like?
Just judging off
He's got a
the
bounce
names
string.
of
Yeah,
the commands he's
yeah.
got.
This is interesting. I mean, you could sit down.
It would
and
take
try
a
to,
decent amount of time to figure
like,
that out.
I'm sure there's a reaction video somewhere. There ought to be where they like pick apart like what each line does.
I mean, he's clearly doing an if and an elif for each.
So the if and elif, what that means is like
Elif
you're going through
if
multiple
the first
different
one
conditions.
doesn't happen,
then you check the next
other
one, and
does.
if that one doesn't happen, then you check the next one, and then the else thing that we saw
I
before.
think this is identifying if it's inside a wall that it'll bounce out.
Oh yeah, because then it would be less than whatever the circle radius is or something like that. Yeah, that kind of makes sense because he's got like the screen get height, the screen get width, like how wide it is going to be and stuff. I think you're right. Yeah. Yep, it's bouncing like you were saying.
It's probably identifying by how far into the wall it is.
You think you'll hit that X and close the window?
Probably, I was saying that earlier.
Yeah.
It would be funny if the ball clips. Just a random thing. It's kind of cool because the existence of ticks is why you can clip. The way you clip is when you're moving, the way you move smoothly is that you're moving by a certain amount each tick. How you clip through a wall is if you're going fast enough that between ticks you never go inside the wall. You go through the wall entirely in one tick so that it skips the collision check.
Interesting. So that
You never actually went through the wall, you just teleported beyond it.
because that's just what would have been the next mathematical scene.
The most iconic clip of all time, the BLJ, is simply designed by the fact that Mario doesn't have a limit to how fast he can go backwards. There's a cap to how fast he can go forwards, but he has no cap on backwards.
So what's the BLJ?
The
big
backwards
backwards
long
long
jump,
jump?
the iconic thing from
And it's
Mario
in Mario
64,
64?
where you just do repeated long jumps backwards on the staircase to go really fast and split through walls or skip the infinite staircase.
Yeah.
So what part did he do?
Hit high. So what did he changed this
So
character.
I
here.
was checking this out earlier.
So he was minusing the circle radius. Now
The way they were
switched
doing
that
it
to
earlier
time.
was by setting up where the bottom of the screen is for an earlier thing. Now he's multiplied it instead of subtracting by it. Basically, he moved one of the walls. I can't tell if he moved it into the void or into the heavens. It's one of the two.
But he affected where the wall's going to
Yeah.
be, and that's going to mess something up here.
And it was specifically the bottom wall.
Fireworks, but this, printing more of those string kind of things.
Yeah.
Oh,
Yeah.
he closed it, just like we were saying. Append nuke?
So he's building a function.
Nuke n is the function he's creating.
Oh,
And then he's building an empty list,
Okay.
looping 10 times, checking if n is greater than 1.
no,
and then
he adds n-1 into
no,
the...
he adds the function
adds the...
with parameters of n being less. Oh.
So he's creating... Wait,
Oh,
is he nesting a loop in like over and
No,
over
he's
again?
nesting it so that the function is creating. So basically, what this will do, if nuke is run, no matter what it's run with, n is going to be set to just say 0,
Uh-huh.
and then it's going to create an empty list,
It
run
won't be
through
greater
10
than-
times, and then
yeah.
add the function, but now with the parameters of n being slightly smaller into that list, but only if n is greater than 1. Otherwise, it just adds the number
Adds the
into
number
that
again,
list.
yeah.
Basically,
He's going to create this massive...
he's going to crash
explosive
everything
list, yeah.
by making.
A list that never ends. Like
That
it's gonna-
just keeps going.
Keeps getting larger. Well, let's watch it blow up the system.
Oh, and he's printing it too.
Syntax error. Did you see that? So it had a syntax error, and then he adds a, this is random right at the end. He hit it,
He turned it into a comment.
turned it into a comment, so now it's not going to error anymore. I just wanted to point that out.
Yeah.
It's kind of quick, blink, you miss it. Okay, I'm going to go back. And then here comes the nuke. Just keeps creating all these digits.
Oh yeah.
It's expanding.
Here's yellow. The whole thing here.
is in the number kingdom.
It's a virtual machine.
Technically, yeah.
Oh, poor guy. Killed it. Oh. Syntax error.
Bluetooth.
Tensors? What are we doing here? He's creating a neural net. I think he's trying to rebuild an AI or something.
Oh no. He's setting up it.
Yeah.
He's re-sentienting the computer.
Yeah. Hello world. Hey, that was what you were saying.
It happened.
He created a neural net. So this is trying to model, I think, artificial intelligence.
Built on Python.
I don't know. I have no idea. I that's not really something I know a lot about. I know some of the basic mathematical ideas behind it, not how to code it. That's cool that he's highlighting when it's hitting what in code. Input hello world. He brought it to life. Hello, yellow. What do you think of it?
It is kind of sad that he never made Snake in it.
Yeah.
It's just a general funny thing to do to put Snake in Python.
Oh, okay. Oh, yeah, sure. Okay, that makes sense. Yeah. I don't know. I think it was cool. Like, it was a lot of fun to watch and react to it. But so
it handled de-escalation really well, which is something Alan Becker always does. It's really funny to see the way that everything goes from just like the basics, to freaking AI.
Yeah, it was really nice. I feel like I learned actually a bit about coding watching this. You know, because this was like of all the things, like with the math and the physics and the geometry, I kind of knew a lot of that stuff going in. But this was like only like basics or whatever that I knew. So it's kind of fun to like learn a little bit about Python doing this. Do you feel like you learned anything? Anything that you didn't know before?
I learned about the freaking like
is digit.
Is digit.
Well, thanks for joining us for our reaction to animations versus coding. We hope you had a good time watching with us and seeing our reactions to it. If you enjoyed this video, please give it a like and subscribe to Scholar Sauce and maybe share it with your friends. We're trying to always grow the Scholar Sauce community. If you missed my reactions to animations versus math, physics, and geometry, you can find a playlist of my reactions to Alan Becker's content here. And if you want to watch some more of my content, you can find this video here where I describe how classic JRPG maps aren't actually spheres. And we'll catch you next time on Scholar Sauce. Wave, Ethan. Come on, wave. There you go.